All right, so we had a special request. Somebody wanted me to do the Tukey's test and put it online as a lecture, so that's what I'm doing right now. So we worked this ANOVA for aspirin versus ibuprofen versus a placebo. And what we're looking for is whether any of these drugs alleviate headache symptoms more quickly. So we wanted to compare aspirin and ibuprofen and a placebo. So we did that, and we got the ANOVA summary table, which looked like this right here. So we had 2 degrees of freedom between groups, 6 degrees of freedom within groups, and the F ratio was 6.8. And remember that an F ratio is just a mean square between divided by a mean square within. And remember that a mean square is just a sum of squares divided by its degrees of freedom. So all these values are related to one another in this table. And we worked on that today as well during the Zoom session. Okay, so we got an F of 6.8. The null hypothesis is that all of these means for all of these groups is exactly the same. And if that was true, then we're going to get an F ratio that's kind of equal to 1. And to the extent that it's bigger than 1, we have to test it against a critical value. So we got 6.8. The critical value looked up on 2 and 6 degrees of freedom is 5.14. The region of rejection is always in the tail, and 6.8 is bigger than 5.14. So we reject the null, and here's the problem. We rejected the null. There's something going on between these means. These means are more spread out than they ought to be if in the population, really, they're exactly the same. The problem is, and it's the problem that Tukey's HSD is going to solve, the problem is which ones are more spread out from the others, because it might just be aspirin works better than the placebo, or maybe aspirin and ibuprofen both work better than the placebo, or maybe ibuprofen works better than aspirin, works better than the placebo, and they're all different from one another, and that's what we're going to need to figure out. So the tool that we have to use for that is Tukey's HSD. And so Tukey's HSD gives us information about the smallest mean difference that can honestly, we need to think on that word a little bit, be considered significant. The smallest mean difference. So when we get done with Tukey's HSD, we're going to have a mean difference. And it's the smallest mean difference between 2 groups that can be considered significant. So when we go back over here, what we're trying to figure out, we're going to have several hypotheses we have to test. One is that mu for aspirin is equal to mu for ibuprofen. And another is that mu for aspirin is equal to mu for the placebo. And the last one is that mu for ibuprofen is equal to mu for the placebo. And we need to test each of those, and for each of those there's a mean difference. So for 5, 7, 8, so we got to find the mean for each of them. And then we have to find the mean difference, because now we're testing not the mean, but the mean difference between 2 groups. So we need to find the mean. And then for each pair of means, we need to find the difference. So we can do that right now. So the mean for aspirin is 5 plus 7 plus 8, which is 20, divided by 3. So I need a calculator. Let's see. I got one over here. So 20 divided by 3. So you work that too while I'm working that. So 20 divided by 3 is 6.67. So this mean is 6.67. And the mean for ibuprofen, I know what that is 5. And the mean for the placebo is 9 plus 8 plus 8 divided by 3. So 9 plus 8 plus 8 divided by 3. So I get 25 divided by 3. I get 8.33. So now we have a mean for aspirin of 6.67, and these hypotheses are going to be tested by comparing aspirin to ibuprofen. So is that 1.67, is that big enough to be a significant difference? And aspirin to the placebo, is that big enough to be a significant difference? And ibuprofen to the placebo, is that big enough to be a significant difference? This difference is the biggest. It looks like it's 3.33. So Tukey's HSD is going to come back with a difference, a mean difference, and any mean difference bigger than that, we're going to consider significant. So if Tukey's comes back with 3, the mean difference, in order to be significant, has to be at least 3 units apart. These means have to be at least 3 units apart. Well, then this is the only significant difference, because this is not 3 units apart, and this is not 3 units apart. So Tukey's going to give us, Tukey's HSD is going to give us that number. So let's figure out what it is. And it's real simple to compute. So HSD is equal to Q, this value of Q, and we're going to look Q up. Q comes from the table. Q on alpha on the number of treatments or means, and on degrees of freedom within groups. And we're going to multiply Q, we're going to multiply it by the square root of the mean square within groups divided by the number of scores in each group. So this is the number of scores per group. This is the mean square within group that we got from our ANOVA summary table. This is the number of scores in each group. This value we're going to get out of a table, like we get T critical and Z critical. It's a critical value. And we're going to look it up on alpha. Your table only has alpha 0.05. On the number of treatments, I think we'll call this K, but it's the number of treatments and degrees of freedom within groups. So let's look at our Q table. So we need 3 things. We need Q, we need the mean square within groups, and we need the number of scores in each group. And the mean square within groups, let's see, let's do it over here. So we need, so Tukey's is equal to, we need Q on alpha, the number of treatments, which we have 3, and degrees of freedom within groups. And then we multiply that by mean square within groups divided by n, the square root of that. So let's see what we have and what's easy to get. I think mean square within groups is easy to get, and n is easy to get. That's just the number of scores in each group and the mean square. So let's go back over here to our ANOVA summary table, because I'm betting it's over here somewhere. So mean square within groups, we need this. And the sample size, so we need 1.22, remember that, 1.22. So mean square within groups is 1.22. The number of scores in each group is 3. So n is 3. And now we have to go find that Q value. So Q on alpha, how many treatments we have? We have 3 treatments. And degrees of freedom within groups, was 6. So we have 6 degrees of freedom within groups. So let's go back over here. So this is 3 treatments, 6 degrees of freedom within groups. Alpha is 0.05. All right, let's go to the Q table. I have mine as a photograph. Okay. So we said that we're going to look this Q up on however many treatments we have. We have 3 groups, 3 treatments, aspirin, ibuprofen, and a placebo. And we have 6 degrees of freedom within groups. So 3 treatments, 6 degrees of freedom within groups. So I get 4.34 for Q. And this Q value is alpha 0.05. We'd have a whole nother table for another one. But so 3 treatments and 6 degrees of freedom within groups, I get 4.34. So let's go back over here. 4.34. So Q is equal to 4.34. All right, so let's put all this together. Let me get rid of that so we can see what we're doing. So HSD, the smallest difference between means that can honestly be considered significant is 4.34 times the square root of 1.22 divided by 3. So we have to take 1.22 divided by 3, take the square root of that, and then multiply that by 4.34, and we're going to get a value called HSD. That's the smallest mean difference that we can honestly consider significant. So I get 1.22 divided by 3. Take the square root of that. Square root of 0.4066 or 0.407. 0.407, and take the square root, I get 0.6377 times 4.34. I get 2.77. So I get 2.77. A difference of 2.77 is the smallest mean difference that we can honestly consider significant. 2.77. Okay, so we're done with that. We have HSD. Tukey's HSD is 2.77. All right, let's go back over here and see what kind of mean differences we actually have to compare to 2.77. So HSD equals 2.77. All right, so I get a difference here between these two, and it doesn't matter positive or negative. This is a two-tailed test. It doesn't matter whether this difference is one way or the other, just what kind of difference is there. And I get a difference between these two of what, 1.67? So the null hypothesis that is comparing aspirin and ibuprofen over here, we can't reject that because it's not bigger. The difference, the mean difference is not bigger than 2.77. The mean difference is only 1.67, and it needs to be 2.77 in order to be considered significant. So this one is fail to reject. Fail to reject. Okay? Now, let's compare aspirin and the placebo. So I get 8.33 minus 6.67. I get 8.33 minus 6.67. Hang on. 8.33 minus, oh, I know what I'm doing wrong. 8.33 minus 6.67 equals 1.66. I get another 1.66 over here. So this between these two, 6.67 and 8.33, these two right here, I get 1.67, and not enough to reject the null. So there's no significant difference between aspirin and the placebo. Bummer. Failed to reject that one as well. Between ibuprofen and the placebo is 3.33. 8.33 minus 5 is 3.33. So these two, 3.33. And that's this null right here, ibuprofen and the placebo, and 3.33 is bigger than 2.77. And so we're going to reject the null there. And usually when we reject the null, we put a little asterisk right there and say that's significant. And when we fail to reject the null, we put an NS right there, meaning not significant, like that. So, I see what this means. So, ibuprofen relieves headache symptoms significantly faster than a sugar pill. But aspirin does not relieve headache symptoms significantly faster than a sugar pill. And aspirin does not relieve headache symptoms significantly slow or significantly faster than a sugar pill. And aspirin does not relieve headache symptoms significantly slower than ibuprofen. So no differences between ibuprofen and aspirin. No differences between aspirin and a placebo. The only difference is between ibuprofen and the placebo, and if it's between those two, you take the ibuprofen. It's going to get rid of your headache symptoms more quickly. That's Tukey's HSD.